Good morning, class. We are looking at Trig trigonometry, practice test number 3, module 3, covering 5.4 to 8, section 5.4, right triangle trigonometry, chapter 8, application of trigonometry, 8.1, the law of sines, 8.2, the law of cosines, 8.3, polar equations. All right, we are given the setting and we want to find CD. There are different ways of approaching it. For example, if you look at this angle, it's a straight angle 180 degrees, therefore the angle ABD must be 144 degrees because the sum of these two must be 180. So if it's 36, this must be 180 minus 36. So this is 144 degrees. Angle BDA, this angle, BDA, this angle, this small one, must be 18 degrees because 18 plus 144 subtracted from 180 gives you 18. Now, isosceles triangle, because these two angles are the same. If AB is known to be 200, then BD must be the same again, because we have a isosceles triangle. That's the definition of isosceles triangles in general. Two sides are identical. Two angles, corresponding angles, are identical. So we want to find this distance. Sine, so in this triangle BCD, sine of 36 degrees is the opposite, which is CD over BD. The hypotenuse, let me shade that. So this is the triangle of interest. So this angle, the sine is the opposite over the hypotenuse. And we showed that the hypotenuse is 200. So CD is the product of 200 and sine of 36 degrees. We use a calculator and we come up with the answer. And as far as the number of decimals, however they ask you. Normally when this is 200, it's 200, we go with only one decimal, but I wanted to show you with more. Okay. Solve the right triangle. A is 8, B is 2, C is 90 degrees. So we put in, and it doesn't have to be to scale, just a general idea. So if A is 8, this is capital A. Is if lowercase b is 2, this is capital B, and C is 90 degrees. So Pythagorean theorem, we want all the sides, all the angles. That's the meaning of solving that. We have two sides. We can find the third one using Pythagorean theorem, a squared plus b squared equals c squared. This is 64. This is 468. So the square root of 68, or remember 68 is 4 times 17. 4 comes out as 2. 8.2. So one angle is known to be 90 degrees. The other ones we can use many, many different ways. For example, tan of B is the opposite B over the adjacent A, 2 over 8 or 1/4. Therefore, 2/8 is 1 over 4. Therefore, B is the tan inverse of 1/4. Using a calculator, we get 0.25 radians or 14.03 degrees. By the way, make sure it's in a proper mode. It's in radian, it's in degrees, whatever that you need. And so the final angle you just subtracted from 90, because these two angles must be 90, or you can say the sum of all must be 180, makes no difference. And we write all the information, A, B, C, the angles, A, B, C, the sides. Just you put all of it in the same spot.
I have a statement. On the answer key, it says that the line AB is actually two radical 5. So is that answer wrong on the answer key?
So this is 2 squared of 5. Is that what you're saying?
Well, no, just saying on the answer key, it says that C is actually 2 square root of 5.
So that's what it
So
says.
is
Two, instead of 2 square root of 17, it says 2 square root of 5, right?
yes.
That's wrong.
Okay. Just wanted to make
Thanks.
sure.
Thanks. Just remind me at the end. I will go look at it, if you don't mind to stay for just a minute.
Okay.
Thank you so much. Could somebody be kind enough to read this, please?
A girl is standing 20 feet in front of the Disneyland Christmas tree. The star at the top of the tree to the bottom of her shoes make a 60 degree. How tall is the tree? What is the distance between the girl and the star? Draw a diagram.
Anytime we have, thank you so much. Anytime we have a case like this, drawing a diagram is a must, so we understand the situation. Without a diagram, it's impossible to solve this. So here's the tree. Here's the star. Here's the distance between the girl and the star. This is 60 degrees. This is 20 feet. So everything that is given here is put here. So from the question, you should be able to come up with this. And without this, it's impossible to answer this. So now, tan of 60 degrees is the opposite, which we are going to call it x, over 20. Therefore, x is the product of these two. Tan of 60, we know it's square root of 3. And we put it into a calculator. And that's what we get. Pythagorean theorem says a squared plus b a squared plus b squared equals c squared. In this case, Tony squared plus x squared. Tony squared plus x squared, which is 36.64 squared, is equal to c squared. You put it into a calculator. It's almost 1600, so c becomes almost 40 feet. Here's the setting. We want to find AC, angle A, angle B. We have SSA, sine law, therefore is in order. SSA, side angle, therefore sine law, which is sine A over A, sine B over B, sine C over C, they're all equal. We have this angle, and we have this side. So sine of 67 over 8 is sine of A over 5. So you do use the three quantities given, right? Sine A is the product of these two divided by 8. We need to use a calculator to find sine A, and then the inverse function will result in sine A. So you have to put this into a calculator that gives you an answer. Angle A would be sine inverse of that value. So we have 1 and 2 angles. The third one, you simply add them up, subtract from 180. So AMC 67 and 35.1. AMC is the sum of these two, which is 102.1. Subtracted from 180, 77.9, almost 78 degrees. So we use that and we find AC. Again, we use this part, sine of 67 over 8. The reason we use this part, this is the part that is given. Always use the given part if possible. Now, sine of 77.9 over AC, that's part of the sine law. And so the cross product here and the cross product here are identical. Therefore, AC is the product of these two divided by sine of 67. Putting it into a calculator will result in about 8.5. And you can write AC, angle A, angle B. So we can write the missing parts.
I have a question for this one. Because it's an SSA, does it fall into an ambiguous case? And but why we saw it just for like one value for each only?
What do we get? One value for each, you said?
Yes, because of this fall into the ambiguous case, because it's
Yeah,
SS.
if you work it out, the other ones won't work.
Yeah.
Okay, because the sum, they will go beyond 180. I didn't check this one. You can check it on your own that there is no other case for this one. So we do have a ambiguous case in the case of a SSA in general, but not in this case. It is clearly given to us. Do you see that?
Yes.
This is the setting is given to us. There is no ambiguous case here. If they give us some values and then you have to work on it, you'll see whether you have an answer or not. But in this case, there is nothing ambiguous about it. Everything is given, even the triangle is given to you more specifically. Just right here. The other angle would be 180 minus that. And you add up to 67 degrees to that, it goes beyond 180. Do you follow what I'm saying?
Yes, I do, yes.
The other angle, if there were supposed to be another angle, would be 180 minus 35.1. That would be the second possible angle. And when you add it to the given angle of 67 degrees, it goes over 180. Okay?
Yes, thank you very much.
My pleasure. So this doesn't exist. All right, let's discuss the SSA. H equals B sine A when H is larger than one side, it fails to be a triangle. When it's less than A, less than B, there will be two. So in this case, A is 3, B is 2, A is 50 degrees. So again, this may not be to scale. Please understand the difference between this one and the other one. The other one, the triangle was given to us. There was nothing ambiguous about it. In this one, we just made this up and it may not be to scale and may end up having no solutions, one solutions or two solutions. We have to go through that. So this, we go through the process to see whether it works or not. So we have the sine law. Sine of a 50. The reason I do the drawing so we know the angles and the opposite sides. But again, by no means this is to scale. So sine 50 opposite A, which is 3. Sine B opposite B, which is 2. Sine C opposite C. And both of them are missing here. So if we use this one, if we use these two, we can get to sine B, which makes it 2 times sine 50 divided by 3. Gives us 0.511. So what is B? Sine inverse of this number. So this is case 1. Sine inverse of that is 30.7 degrees. 30.7 degrees, everybody. Now, case 2, B is 149.3 degrees. How do we get that? Sine is positive in the first and second quadrant. So B here is 180 minus 30.7 degrees. It's not possible. Why is that? Anybody? So this is ambiguous case, we got one of them, okay, and then we got the second one. So there are two cases, but we are saying this is not going to work out because A is given as 50. Add 50 and you get almost 200 degrees. The sum of these two must be less than 180. If the sum of these two angles is less than 180, then there's a third angle, and that works out. But because it's more than that, it fails, so there is no way. So we just continue with this case. So now we have 50 degrees plus 30.7 degrees, and we subtract it from 180. Right, so again, the sum of all three angles must be 180. So this is 180 minus the sum of 50 plus 30.7. That's how we get that. And now we go back up here. Okay, and the first one and the last one. Again, I like to use the given, what we have. Okay, sine of 50 over 3 is sine of c, which we found it to be 99.3 over lowercase c. And so lowercase c is the product of these two numbers divided by sine of 50. So let me just quickly show you this step. So c equals 3 sine of 99.3 degrees over sine of 50 degrees. Okay, and here's the synopsis of everything. Again, there definitely we are dealing with an ambiguous case, but it either works out or it doesn't. Try and solve the triangle. A is 8, B is C, C is 6. Again, these are all sides, right? S, S, S. We use a cosine law there. Again, this may not be to scale. Whenever we have all sides, in order to find an angle, we have to use this formula to find the angle A. So cosine A is B squared plus C squared minus A squared over 2BC. Well, B squared, 9, C squared, 6, minus A squared, 64. And the bottom is 2 times 3 times 6. 9 and 36, 45 minus 64 is negative 19. 2 times 3 times 6 is 36. Therefore, A is cosine inverse of this number. Remember, cosine goes from 0 to pi as far as the inverse function is concerned. So it gives us 121.86 degrees. And now you have two choices, class. You can continue with the cosine law and let's say find cosine B in the same manner. Or now that one angle is known, you can use the sine law. Now you have a choice. But just for the sake of argument, we are still dealing with the cosine law. We're going to continue on that thoughts. Cosine B is a squared minus c plus c squared minus b squared over 2ac. If you notice here, because this is a, this is the one that you are going to have minus a squared. So because this is b, you're going to have minus b squared. Again, you don't have to do that. You can use the sine law. You have a choice. So a squared is 64, c squared is 36 minus b squared is 9. So 64 and 36 minus 9, 100 minus 9, 91 over 96. So this is 91. Over 96. So B is cosine inverse of that. We get 18.57 degrees. We add these two, subtract from 180. So we add these two and subtract from 180. In other words, this is 180 minus the sum of 121.86 plus 18.57. That's how we get that. The last one is easy. All right, we are given B and C, two angles and one side. Side angle, angle. Obviously, we can easily get to the third angle. So again, we do some drawing. Again, class, it doesn't have to be to scale. This is just to show you what we have, and it may be completely off. But we have the three angles. We have the side C equals 5. And so the very first thing, add them up, subtract from 180. That would be the two angles given, and the last one is 40. Okay, so this one is 40 now, okay? So, in fact, by the way, generally speaking, the larger the angle, remember that, the larger the angle, the larger the side opposite. That's why sometimes it may not be to scale before we have all the information. So we may draw something and then you can adjust it accordingly. So now that we have all angles on one side, we have to use that side, and then the rest of them works fine. Sine of 95 and C equals 5. This we must use, and then doesn't matter which one. Sine of 40 over A, for example. And A would be the product of these two numbers divided by sine of 95. And it gives us one side, A equals 3.23. Again, we're going to use this one. Why? Always use the given, because what if we made a mistake in the process of finding everything else? Always use the given if possible. Now, this one now, sine of 45 over AC or B, okay? AC or B. And so the product of these two divided by sine 45, my apologies, sine 95. It's B, and therefore you write all of it. Again, since it was mentioned by one of the fellow students, you do have the key, and my assumption is, my hope is that you guys have worked on all of these. So now it makes it nice and easy to move on easy. So A is 40 degrees, lowercase a is 3.2, and lowercase b is 3.5. So everything that we found. We want to solve this case. A is 55 degrees, C is 20 degrees, A equals 4. And again, sine law, and again, it may not be to scale. So clearly 55 plus 20 subtracted from 180. That would be the very third angle. Okay. So when two angles are given, the third one comes easily to us. The total sum of the interior angles must be 180. And so we are going to use the sine law, and we are going to use the fact that this one and this one are given. Okay, sine of 55 over 4. Sine of 55 over 4. So sine of 105, this one is 105, and this one is let me write. This one is lowercase. So b is the product of these two divided by sine of 55. This is sine, everybody, I think. Sine of 55 times b. And so b is a 4 sine 105 over sine of 55. I wanted to show you this one with a little bit more details. Okay. Sine of 105 over 4.77, sine of 20 over c, and c would be the product of these two over sine of 105. Now, I did that, but I highly recommend you check, okay? I highly recommend you use this one. I've done this on purpose. I would use this one instead. Why? Because it's given. What I wanted to show here that it happened to work out. I've checked it, so it works out, but it's really a good practice to put the given one. And here's the summary of everything we found. Use the law of cosine to prove cosine A over A, cosine B over B, cosine C over C. They add up to A squared plus B squared plus C squared. And we have the sine law, we have the cosine law, and we have cosine A here. First, we are going to start with one side and take a common denominator. Obviously, this is a more complicated side. We're going to start with that one. So this side, and when we take a common denominator is ABC. So cosine A times BC, or BC times cosine A. Cosine B times AC, or AC times cosine B. Cosine C times AB, or AB times cosine C. So this is just taking a common denominator, everybody. Taking a common denominator should not be a big deal. I go back to this one. And I notice the denominator is 2BC here, the denominator is ABC. if I put the BC here, I get BC cosine A. If I put the BC here, look at the top. If I multiply by BC, so multiply this one by BC and this one by BC, you get BC cosine A, right? So if I multiply it, I get BC cosine A. And this right side, the denominator goes to number 2 and 2 only. By the same token, I can go and find the rest of them in the same manner. So this comes from here, everybody, okay? Multiply both sides by BC. We do the same thing here. We do the same thing here.
So I have a question. So the reason why there's a 2 at the bottom is because
I
BC
kept the 2.
canceled out. Yeah.
See, I kept the 2
So,
here. So I'm saying
and that's
this one,
because,
if you multiply by BC, this is what you get.
right.
Just multiply this one by BC.
Okay. And then that's how the two
And it's
BCs cancel
BC
out.
cosine A.
Okay.
So I can replace BC cosine A by this expression, right, everybody? I can replace AC cosine B by this expression and AB cosine C by this expression. Again, take a look at this one. Let me write it here. Cosine A is B squared plus C squared minus A squared over 2BC. Okay, if I multiply this by just BC, why BC? Why BC? Because I want to get this one. So the left side becomes BC cosine A. The right side BC cancels out the BC. We get B squared plus C squared minus A squared over 2. Is everybody okay with this class? So what we are saying is that this, we want cosine A to look like BC times cosine A. So multiplied by BC. That's all I'm saying. We know this. How do you make this look like BC cosine A? Multiplied by BC. When you multiply by BC, the right side, the denominator goes away, but the 2 doesn't go. So let's replace this with that, this one with that, this one with that. And all of them have a denominator 2. So what happens, this denominator 2 goes down. So again, put this in here, put this in here, and put this here. All of them. In other words, to begin with the first one class, let's see what color do I want to use here. This one is B squared plus C squared minus A squared over 2. Actually, I use its own color. The other one is green. So plus, now this one is A squared plus C squared minus B squared over 2. The last one is yellow, plus A squared plus B squared minus C squared over 2. So this is what we have. Okay, everybody. The first one I then use the proper color, just like that. reddish purple. All of them have a denominator 2, so you can just take it down. I hope you see that. This is a complex fraction, everybody. So this is b squared plus c squared minus a squared. This is a squared plus c squared minus b squared. And this is a squared plus b squared minus c squared. So start canceling things out. Like these two. Like these two. Like these two. And you end up with the right hand side. So that's the right hand side. Okay, this took too much time. Class, we have a lot to do. An aircraft is spotted by two observers who are at 1,000 feet apart. As the airplane passes over the line joining them, each observer takes a sighting of angle of elevation to the plane, to the plane, as indicated in the figure. How high is the plane? So this is the situation, everybody. So let's throw in what we know. If we call this H, we call this Y, we call this R. Now, P, R, Q, this angle is 105 degrees. 105 because 40 plus 35, 180 minus the sum of 40 and 35. That's why, okay? And we know these angles. How do we know these angles? Because, let me shade one of them. Let me shade, for example, this one. Each side is a right triangle. This is 90 degrees, this is 35 degrees. So 35 subtracted from 90 gives you 55. This is 40 subtracted from 90 gives you 50. So that's pretty obvious. And so we are going to use a sine law. This one, sine of 105. And this one, sine of 35 over y. We get, all we have to do, calculate one of those sides. It doesn't matter this side or that side. And so y is the product of these two divided by sine of 105. And y or PR has this value, almost 594 feet. And now, since this is 40 degrees, we can say sine of 40 degrees is the opposite h over the hypotenuse y. And since we have the value of y, then h is the product of these two. And it's 381.69, almost 382 feet. Could somebody read this quickly, please?
Two homes are located on the opposite side of a small hill. To measure the distance between them, a surveyor walks a distance of 50 feet from house P to point R. Use a transit to measure angle PRQ, which is found to be 80 degrees, and then walks to house Q, a distance of 60 feet. How far apart are the houses?
So these are the two. Okay. So we have the two houses, if you will, 50 feet away, 60 feet away, creates this angle 80. And so this is what we have in effect, in essence, 50 feet, 60 feet, R, and this angle is 80. So again, we have the two locations, two houses, whatever. You just pick from one and go away however many feet, okay? And the same thing here. So you can, the bottom line is you can measure these two distances. What you cannot measure is this distance. And this is 80 degrees. So you have SAS. So you can use, cosine law, okay? A squared, this is in essence the A or PQ. So A squared is B squared plus C squared minus 2BC cosine A. Because we have two sides and the included angle, the missing side can be utilized by cosine law. So PQ squared or A squared is 50 squared plus 60 squared minus 2 times the product of these two and cosine of 80. All you have to put it into a calculator and then take a root, and it's almost 71 feet, 71.12. Again, it's important to understand what's given in the first place, everybody. Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One has traveled 300 feet and the second one 350 feet. How far are these boats apart? Draw a diagram. So we have two. Starting from point A. They start from point A. Different directions. This angle is 135 degrees. This goes away by 300 feet. This goes away by 350 feet. And again, by no means this is to scale. We want to know how far apart they are. That means you have side angle, and therefore you are looking to use the cosine law, which says a squared is b squared plus c squared minus 2bc cosine. Again, two sides and the included angle are given. What is the third side? That's the concept. So a squared or bc squared is 300 squared plus 350 squared minus 2 times the product of the two and cosine of 135 degrees. Now, basically, you plug in to a calculator and you end up with a squared. So these are the values. Of course, cosine of 135 is the same as cosine of 45, but negative in the second quadrant. So that's why I wrote it's a common arc, minus square root of 2 over 2. You take a root of this number and you get almost 601, so 600.83 feet. Two cars leave an intersection together traveling on courses with an angle of 45 degrees between them each. If each travels 500 feet, how far apart? Draw a diagram. And clearly we are looking at the case. The theta is 45 degrees. Each one is 500. And this is what is missing. So this is a diagram, and it clearly explains that basically we have two sides and an included angle, and we use the cosine law. We use the cosine law, okay? So in this case, c squared is a squared plus b squared minus 2ab cosine theta, if you call this a and b. And so 500 squared plus 500 squared minus 2 times the product of 500 and 500 and cosine of 45 degrees. Again, I leave it to you to use a calculator and convince yourself C is about 382.68 feet or 383 feet. Basically the same situation, but this time the angle is 30 degrees. One of them goes out 1,000 feet, the other one 720 feet. So exactly the same situation. Numbers are different, class. So this way, this is the angle, 720 and 1,000. So basically we use the same formula, but this time is this side that we want, and it's 1,000 squared plus 720 squared minus 2 times the product of the 2 times cosine of 30 degrees, and cosine of 30 degrees is square root of 3 over 2. and you put it into a calculator, you come up with the same with a proper answer. Almost 521 feet, 520.89. Class, these two questions are practically the same. We just have different numbers, okay? George is standing 35 feet in front of a house and notices that the angle of elevation from eye level to the top of the house is 60 degrees. Find the height of the house and draw a diagram. Okay. So remember, it's a horizontal line. This is the angle of elevation. If you look up, angle of depression. If you look down, so in this case, George, okay, from the eye level, again, this may not be to scale, that represents the eye level. That represents the angle of 60 degrees. This is the distance of 35 feet. This is the distance we are interested in calculating. So again, look at the setup. So tan of 60 is h over 35, and h is 35 times tan of 60, and tan of 60 is square root of 3. It's one of those common arcs. So 60.62 feet. George is standing 27 feet in front of a house on a hill and notices that the angle of depression from eye level, the top of the house to its bottom, is 73 degrees. Find the height of the house. So again, reminding everybody about the angle of elevation versus the depression. So what it says, here's the house. He's standing up here. Here's the eye level, okay, from the top to the bottom. This angle is 73 degrees. This distance is 27 feet. This distance is what we are looking for. So h, the height, is of interest to us, which is tan of 73 degrees is the opposite h over the adjacent 27. The opposite is h, the adjacent is 27, so h is the product of these two. 27 times tan of 73 degrees, you put it into a calculator, it's 88.31 feet. I want to remind you of the following. If you have two parallel lines, A, B, and C, D, intersected by a transversal line GH, it creates a bunch of angles, and they have different names. So the figure shows two parallel lines, A, B, and C, D, intersected by the transverse line GH. Corresponding angles are equal if the transversal intersect at two parallel lines. So these are the two lines that are parallel. This is the line that crosses them. Corresponding interior angles found at the inner side of the intersection between the parallel lines and the transversal. Corresponding exterior angles found at the outer side of the intersection between the parallel and transversal. I wanted to remind you. So as far as the rest of this, what I want to explain is this. Just look at, I mean, if you just look at it, you can see that these two are equal. These two are equal. These two are equal. These two are equal. 1 and 5 are equal. So it's easy to see what angles are equal. So when you have two parallel lines and a line that crosses both of them, it creates 4 and 4, 8 angles. So what is also interesting, for example, number 3 and 6, they add up to 180. Number 1 and 3 are equal. 1 and 2, they add up to 180. So some of them are equal, some of them are supplementary. Okay. 8 and 7, they add up to 180. They are supplementary. Okay. 8 and 5, supplementary. 5 and 8, supplementary. Okay. But 8 and 6 are equal. 5 and 7 are equal, so on and so forth. So I just wanted to remind you of this concept so we can move on. A balloon is flying at a height of 600 feet directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram. Again, I want to explain this. To me, it's impossible to come up with an answer without drawing a diagram. And I'm reminding you, this is in feet, this is in miles. Therefore, we should know 1 mile is 5,280 feet. So here's the balloon. 600 feet, airport. This distance is 5 miles. This angle is of interest to us. So this is the setup. What is the angle of depression? Now, these two are equal. So if I can find this is the same as this one, because what we just did in the previous page, the terminology is alternate interior angles. So these two angles, because these two lines are parallel, these two angles are identical. So if I find this is the same as this one. So how do I find this? If you look at this triangle, tan of theta is the opposite 600 feet over 5 miles. Now, again, feet versus mile. We must change either this one to feet or this one. Either this one multiplied by 5280 or this one divided by 5280. Either way is fine. They must become of the same unit. Now they are both feet. Over feet. Using a calculator, we get 0.022727. Tan inverse of that, you're putting it into a calculator, results in 1.3019485. So if we stop here, 1.302 degrees. A rocket takes off at a bearing of north 30 degrees east. After flying for 900 meters, the pilot turns 90 degrees and heads northwest. After flying for 1,000 meters, what is the new bearing of the plane? Draw a diagram. So everybody remembers this. And so, for example, this is missing. So it's south 20 degrees east. So north 30 degrees east means this way. So this is the way it goes. Okay, north 30 degrees east. And we go for how long? We go 900 meters. Then we turn 90 degrees. When you turn 90 degrees, you can go this way or this way. 90 degrees, one of the two. We are going northwest. So we're going to go this way, everybody. And we're going to go for how long? 1,000 meters. Now, what is the new bearing? Now, take a look at this one. If we call this alpha, everybody, the new bearing, if we call this alpha, the new bearing is north alpha west. So all you have to do, find alpha. And bear in mind, we know this one to be 30 degrees. So this angle, if we find it, then alpha would be whatever we have minus 30 degrees. So again, I want to make sure that we understand that we have this one. So this is given as 30 degrees, okay? So tan of theta is the opposite 1,000 over the adjacent 900, and the tan inverse of that results in 48.0127, okay, or 48.01 degrees. So alpha would be this complete angle minus this 30 degrees. 18.01. So again, we use this triangle to find this theta. Because we know this one is 30 degrees, this one would be theta minus 30 degrees. So alpha is theta minus 30 degrees. So north, 18.01 degrees west. Anybody want to read this quickly for us, please?
An aircraft leaves an airport from a runway with a bearing of n 40 degrees east after flying for 1.5 miles. The pilot turns 90 degrees and heads toward the southeast. After flying for 1 mile in this direction, what bearing should the control tower use to locate aircraft? Draw a diagram.
Excellent. So without a diagram, it's impossible. So we are starting with north 40 degrees east. That's what we start with. Okay. So we go with half a mile, and this is 40 degrees. And then when you make a 90-degree angle, you can go either way, okay? Either up here, down here. So which one? Southeast. That's why we go down there. And that's a 90-degree angle. This we go for 1 mile, and this is now what we are interested in. If we have this angle and we have this angle and we call this angle alpha, then we are going what? South, alpha, east. So this is the bearing. All you have to do, find alpha. So let's find alpha, everybody. So I hope everybody's clear. So south, alpha, east. Notice what's happening. If we call this theta alpha and theta and 40 degrees, they add up to 180. So alpha, theta, 40 degrees, they add up to 180 degrees. So if I have alpha, I can find theta. If I have theta, I can find alpha. All I have to do, look for theta. Because I'm interested in finding alpha, I'm going to find theta in this triangle. The tangent is the opposite 1 mile over the adjacent half a mile, which makes it 2. 1 over 1/2 is 2. Therefore, theta is tan inverse of 2. Another common arc, use a calculator, and it gives you 63.43 degrees. And we said all of them add up to 180. So if I subtract 40 plus 63.43, which makes it 103.43 from 180, I get my alpha, which is 76.57 degrees. And so now south, 76.7 degrees, east. We found that. Again, class, questions that you come across here that are basically word problems, they are impossible to solve without a setting. We want to plot the points, and let's remind everybody of a rectangular coordinate system versus polar coordinate system. So this is the origin, and this is the pole. This is the x-axis, this is the positive side of the x-axis, or the polar axis. And polar we represented with r theta, whereas this one we represented with x comma y, and x comma y is unique, but r theta, there are infinitely many of it. So in this case, we want r theta. You always start with theta, which is 0 degrees. If it were positive 2, we would go 2 tick marks on the right. Because it's negative, we go on the left side. 1 pi over 2. Remember, class, this is 0, this is pi over 2, this is pi, this is 270 or 3 pi over 2 back to 2 pi. So pi over 2. This is pi over 2 and 1 tick mark. Okay, 1 tick mark is the answer. Find other polar coordinates for part B, 1 comma pi over 2. And I'm going to remind you that polar having coordinates r theta, I can add even multiples of 2 pi plus 2k pi. K is an integer. If I add odd multiples of pi, so even multiples of pi is 2k pi, odd multiples of pi is 2k plus 1. Then I can negate this and it becomes the same thing. So in this case, it says r is positive, but I want it to be between 0 and minus 2 pi. All I have to do, subtract 2 pi from this to make this negative. Gives me negative 3 pi over 2, and r doesn't change. Since we want r to be negative, let's negate that and make this negative 1. According to this, all I have to do, add a pi, because I want it to be positive between 0 and 2 pi. Add a pi, and that gives you 3 pi over 2. If I want it to be between 2 pi and 4 pi, I'm going to add a 2 pi here, and it gives me a complete revolution and more. It's between 2 pi and 4 pi means go beyond a complete revolution. So add a 2 pi, and that gives you 5 pi over 2. Again, just reminding you the basics. Plot the points first, then find their coordinates, find the rectangular coordinate 6, 115 degrees, and notice the information here. So this is 150 degrees, and you go 6 tick marks, assuming each one represents 1, 1, 2, 3, 4, 5, 6. That's how you locate that, okay? And we want, this is r comma theta. We want to find the rectangular coordinate. And to do so, let's remind everybody that polar has coordinates r comma theta, rectangular has coordinates x comma y. X is r cosine theta, y is r sine theta. Okay, so x is r cosine theta 6 times cosine of 5 pi over 6. Cosine of 5 pi over 6 is the same as pi over 6 or square root of 3 over 2, but negative in the second quadrant. Minus square root of 3 over 2. It's a common arc, so minus 3 square root of 3. Y is r sine theta. Sine of pi over 6 is the same as pi over 6, and it's positive in the second quadrant. Sine of pi over 6 is 1/2, so 6 times 1/2 or 3. So 6 comma 150 is the same as negative 3 square root of 3 comma 3. Very straightforward, everybody. We want to find the polar coordinates. Well, 2 comma negative 2, so 2 to the right, 2 down. That's the locate. That's the, okay, remember, this is now your rectangular grid. 2 to the right, 2 down, okay? So that is graphing or plotting the point. Now we have the following. X squared plus y squared is r squared. Tan theta is y over x. You adjust for the quadrant. So to find the r, x squared plus y squared equals r squared. So 2 squared and negative 2 squared. This is 4 and 4 is 8. So r is square root of 8. And 8 is 4 times 2. 4 comes out as 2. So 2 square root of 2. Everybody knows that. Tan theta is y over x minus 2 over 2 or minus 1. And theta is negative pi over 4. If you want to go with the positive, you add 2 pi and you make it what? 7 pi over 4. So what it means, r is 2 square root of 2. Theta is minus pi over 2, minus pi over 4. So the pair 2 comma negative 2 in rectangular coordinate format is the same as 2 square root of 2 minus pi over 4 in polar coordinates. And again, If it's not specified, you can go with whatever you want. Normally, we want the positive, everybody, okay? Normally, we like to have the positive.